In this tutorial, we are going to create an analog clock. Clocks might sound boring, but they are good examples for learning. Let's take a look at the finished result so you know what you will be making. Here in the Properties panel, we have 3 controls for choosing the time: the number of hours, minutes and seconds. Currently, they all say 0. Changing them changes the time of the clock. Notice that when I adjust the minute hand, you can see that the hour hand moves like it should automatically, reaching halfway through the hour whenever the minute hand reaches 30. No matter which time I choose here, the hands will always be in the right location. The time you choose with these controls is the time the clock will have on frame 0. If we set it to 1:45:25, it will be the starting point of the animation. When we press play, the clock starts ticking and will continue to do so until the timeline ends. The speed of the clock is determined by this speed FPS value. This is the number of frames it takes for the clock to go 1 second. If we set it to the same as the frame rate of our scene, the clock will run in real time. If we give it a larger value, it will go in slow motion, since it takes more frames for it to go 1 second. And if we give it a small value, it will spin like crazy. We have one last property to look at, and that is the hand pause. This determines how smooth the second hand moves. Now when it is close to 1, it stands still almost the entire time, making it sharply jump between each second. When I set it to 0, it flows completely without making a stop. And if I set it to 0.5, it stands still half the time and moves half the time. The clock only has one physical control, this empty. You use it to move, rotate, and scale the clock to fit whatever you want. And that's it. So, let's get started. Before we start with any of the controls, we will create the meshes the clock is made up of. Let's start by creating the clock face. Delete the default objects, add a circle, and rename it clock face. Change it to 64 vertices so it becomes a bit smoother, and fill it with triangles. Let's enter edit mode and rotate it 90 degrees around X. When I rotate and scale objects, I always do it in edit mode, so I don't affect the actual scale and rotation of the object. As you can see, the object still has a rotation of 0, 0, 0, even though I just rotated the circle. If I had done it in object mode, it would say 90 degrees, and I would have to apply the rotation to get rid of it. Let's add some thickness to the circle by adding a solidify modifier and increase the thickness to 0.07. As you can see, the polygons are very visible around the edge, which doesn't look very nice. To improve the shading, we can set it to smooth and then add an edge split modifier to get these sharp and nice edges. Just give it a simple white material and the clock face is complete. Before we create the actual hands of the clock, we will add the shaft in the center that all the hands will be connected to. To save some time, we can just copy the clock face, rename it shaft, scale it down in edit mode, and set the thickness to minus 0.07 so it points in the other direction. Now let's create the first hand by copying the shaft cylinder and rename it hand hour. When I name several similar objects, I always write their common word first, which in this case is hand, so they will be after each other in the outliner. Increase the size so it stands out from the shaft. We don't want it to touch the actual clock face, so move it minus 0.03 along Y and change the thickness to 0.02. We now have the base for the first hand. I will create the bases for all 3 hands before I actually make them point at anything. To create the minute hand base, just duplicate the hour hand base, move it minus 0.03 units along Y, and shrink it slightly. Rename it, and repeat it all one last time for the second hand. Move minus 0.03 units along Y, shrink, and rename. Now we have the base for the 3 hands. Before we finish their shape, let's change their color to black, gray and red to make them easier to see against the clock face. Make the material single user and change the color. Now, to turn them into actual hands pointing at something, we are going to move some of the vertices away from the center. With the hour hand selected, enter edit mode and select the top vertex. Activate proportional editing. If we now move the vertex up to where you want the top to be, we can adjust the fall off of the proportional editing to get a shape that looks good. The hour hand is the shortest of the three, so something like this will do. Remember that because we are making these changes in edit mode, the origin point remains in the center. This will make them easy to rotate later on, since we want the point of rotation to be in the center of the base. Repeat these steps for the other two hands. The minute hand is the longest of the three. To stop the point from being too pointy, we can grab these two vertices below the top and move them up, making it more flat. The second hand should be between the minute and hour hand in length. And now we have our three hands. Currently, it is a bit hard to see what they are pointing at, so let's add all the different points around the face showing the minutes and hours. To create these points, we will take a small cube and then repeat it around the face using an array modifier. Add a cube and give it a black material so it is easy to see against the clock face. Enter edit mode, scale it down, and place it where the first point should be. Since we placed the point in edit mode, the origin point remains in the center, which will be important now when we are going to wrap it around the clock. Add an array modifier. There are 60 minutes in an hour, so set the count to 60. To make them wrap around the clock face, we will add an empty and use that as an offset. Add an empty, remove the relative offset from the array modifier, and add the empty as the object offset. If we now move the empty, the points gets the same offset. Since the origin point is in the center, we just want the copies to rotate without actually moving. What we want to do is to rotate the empty so the points gets evenly spaced around the clock face. There are 60 of them and there are 360 degrees in one rotation, so we need to rotate it 360 divided by 60 degrees, or 6 degrees. And now they are evenly distributed. Let's rename it points minute. The minute points are done, so let's add the hour points. Just copy the minute point, enter edit mode, and change the shape to something larger. Since the position of the minute points won't be changed anymore, we can apply their array modifier. This frees up the empty to be used to position the hour points instead. There should be 12 hour points, so change the count to 12. To make them evenly spaced, the rotation of the empty should be 360 divided by 12, which is 30. It already has a rotation of 6 from before, so let's add a 24 for a total of 30 degrees. And now it is evenly spaced. Apply the array modifier and delete empty since it has done its job. Let's rename it points hour. We can now go in and delete the minutes points that are covered by hour points. This is not something you have to do since they won't be visible, but it is always good practice to remove geometry you don't need. We now have a complete clock mesh, and all the hands has the origin point in the center, making them easy to rotate. Great! Now it is time to make the hands move when we play our animation. Usually I always want to use an armature when I do any kind of rigging. That way, every control and keyframe gets collected in one place, making it much easier to work. In many cases, it is possible to do the same kind of rigging using several separate objects as controls instead of bones, but that can often make things harder to organize and work with. Rigging with objects has a couple of benefits though, and that is that you can control and move things in object mode without having to switch to pose mode. And when you add custom properties, they will always be available in the properties panel since you do all your changes in object mode. So rigging without armatures is absolutely useful in the right situation. One of those situations is when the rig has very few physical controls, preferably just one. When there is just one single control for the user to move around in the viewport, we can do the rigging using objects and still get the benefits of an armature, collecting all controls and keyframes in one single place. The latter had multiple controls in the viewport, while the clock will only have one. This is the reason I rigged the ladder with an armature, but I will rig the clock with objects, or more specifically, empties. An empty is an object that is just used to affect other objects and they never show up in renders, much like armatures. But unlike armatures, they are extremely simple. They only have a location, rotation and scale. And that's it. Everything it does is being a single point in space, used to affect other objects. To make the hands move when we play our animation, we are going to use an empty that holds the current time through its position, and then use that position to drive our 3 different hands. Let's add an empty, and name it time. Move it a bit to the left so it is easier to see. This empty is going to move with a constant speed along C, giving us the master time that will drive the different hands. So, let's add a driver to the C location and open the driver window. This C location will hold the current time in seconds, so we need it to increase when we play the animation. When an animation is played, the current frame in the timeline is increasing. So to make a driver affected by time, we will include this current frame in our driver. We can do this by simply writing frame. Frame is already a defined keyword we can use by default, so there is no need to add a variable that gives us the current frame. Now when I move along the timeline, you can see that the empty moves upwards. Its location in C is now the same as the current frame in our timeline. We want the time empty to move 1 unit for every second, but currently it moves 1 unit for every frame. So we need to divide var by the frame rate of our scene, 30. That way it will take 30 frames to move 1 second. And now when I press play, the empty moves 1 unit per second. Since the current time is now defined through the position of the empty, we can make the hands display that time. Let's start with the second hand. Add a driver to the Y rotation, the axis it should rotate around, and change the variable to use the C location of the time empty so we get the current time. Set the expression to var, and now the hand rotates when the empty moves. However, we only want it to rotate 1 second on the clock for every unit the time empty moves. 1 second should give 1 second. Currently, it is moving much more. So, we need to multiply var by something so it rotates the correct amount. We want 1 second on the timeline to be 1 second on the clock, so we need the hand to rotate 1/60th of a rotation for every unit the empty is moved. The rotation is measured in radians, which means that instead of one rotation being 360 degrees, it is 2 pi. Since one rotation is 2 pi, and we want 1/60th of a rotation, we want to multiply var by 2 pi divided by 60. We can simplify the expression a bit by multiplying the 2 into the 60, getting times pi divided by 30 instead. And now the second hand is at 1 second on the clock when the time empty is at 1. For the minute hand, we can just copy the driver of the second hand as a starting point. The minute hand should be moving 1/60th of the speed of the second hand, since the minute hand should move 1 step when the second hand has moved 60. So, we can just add divided by 60, or to simplify, we can multiply the 30 and 60 and change it to divided by 1800 instead. To check if it works, we have to zoom out the timeline a bit. And it does. The minute hand points at 1 after the second hand has completed 1 rotation. Copy the driver and paste it to the hour hand. The hour hand should be 12 times as slow as the minute hand, since it should move 1/12th of a rotation for every complete rotation of the minute hand. Add divided by 12 to the expression, or simplify by just changing to divided by 21,600. Since an hour is even longer, we have to zoom out the timeline even further to see so everything works. And it does. The hour hand points at 1 after the minute hand has completed 1 rotation. The clock is now displaying the correct time. However, I would like if the second hand jumped between each second instead of moving smoothly. We can make it stick to every second point by adding a floor function to the driver. What it does is simply removing all decimals, so the time value will always be a whole number, making it stick to whole seconds. Unlike a rounding function, this only removes the decimals. This means that a value of 4.99 will still become 4. It will only become 5 once it actually reaches 5, which is what we want, since we don't want the hand to point at 5 after just 4.5 seconds. So add a floor function around var. This gives us whole seconds, and then pi divided by 30 gives us the correct angle. And now the second hand jumps between the points on the clock when I play the animation. We will make this a bit more advanced later on, but this simple jumping between seconds will do for now. Now it is time to give the user control instead of just having the timeline decide the current time. Just like with the ladder, we want to add all custom properties to the object we will be using to move it around, so everything gets collected in one place. So to be able to add our custom properties, let's add a sphere empty. This empty will be used to place the clock in our scene. Since it to the user will be the entire clock, let's rename it clock. Let's scale it down a bit. I will change the size in the object data panel so only the displayed size is changed, not the actual size of the object. If we look in the properties panel, we can see that it still has a scale of 1. Now when we have the empty that will control everything, we can start adding the custom properties that will set the start time of the clock. These controls will change the position of the time empty so we can change the current time of the clock, regardless of the current frame in the timeline. There will be 3 controls: the number of hours, minutes and seconds. You can set the range to be as large as you want for these controls, it doesn't matter. However, allowing large numbers can be a bit confusing, since a value of 100 hours is the same as 4 hours. Therefore, I will limit my values to the actual values possible on a clock. That is 0 to 11 for the hours and 0 to 59 for the minutes and seconds. So, with the clock empty selected, let's add the hours property, set the range from 0 to 11, and remove the decimals so it only allows whole numbers. Add a minutes property, set the range from 0 to 59, and remove the decimals. Do the same for the seconds property. Let's also change the values of the controls to 0 so they don't affect the current time right away. Now we have the controls we need. All that is left to do is to have them affect the time empty. Open the time empty driver and add our 3 controls as variables. We are going to have to add 3 separate parts to this expression, one for each of our controls. Let's start with the seconds. Since we for every second added through our control just want to add 1 second to the current time, all we have to do is to add seconds. Now when I adjust the second control, you can see that the second hand moves 1 second at a time for every second I add. For every minute added via the control, we want to add 60 to the current time. So write plus minutes times 60. Thanks to the order of operation in math, all the multiplying and dividing will be calculated before the addition, so I don't have to add brackets around every separate part that should be added together. However, it does make it easier to read and see what happens, so I will do it anyway. And now the minute control is working. Notice how the hour hand moves with the minute hand. This happens automatically because we are adding 60 actual seconds to the current time instead of just rotating the minute hand object directly. And finally for the hours, we want to move it 3600 seconds for every hour. So write plus hours times 3600. And that's it. Now all controls work like they should, giving us the ability to select the time we want, while also having the time increase automatically when we play the animation. However, I would like to be able to pick the speed of the clock. Currently, 1 second on the clock will always take 30 frames. Let's give the user the ability to easily change this by adding another control to our clock empty and name it speed FPS. I name it speed so it is clear what it does, but I also want to include the unit of the speed, frames per second, or FPS, so the user doesn't have to try different values to figure out how it behaves. For the range, we can set the maximum as high as we want. The higher you allow, the slower the clock can go. In our time empty, we now want to remove the 30 from the expression and add this control instead. Add the variable and adjust the expression. Now I can choose the speed of the clock using the speed control. By keeping it the same as the frame rate of our scene, 30, the clock will run in real time. But now we can also make it move faster or slower, both which might be useful depending on what you're doing. Just to test, set the speed to 0.01 and it will spin like crazy. But what if we set the speed to 0? Will the clock move infinitely fast? No, it won't. It will just stop working. The driver now has an error saying the expression is invalid. This is because we are dividing with our speed value, and since you can't divide by 0, the expression fails when speed is at 0. So, let's change the minimum value of the speed property to something slightly larger than 1. And click OK. Set the current value back to 30 and activate the expression of the time empty again. And now it works like it should. Great. Finally, I would like to be able to change the motion of the second hand. Currently, it instantaneously jumps between the seconds without any actual motion. It would be better if the hand actually swept between each second, and if the user could control the speed, they could easily choose different styles, making the hand move smoothly without stopping at all, jumping quickly, or even something in between. So, let's add a hand pause property to the clock empty. This will control how smoothly it moves from one second to the next by changing how long it stands still. I will give it a value of 0.8 because it will make testing and understanding the creation of the control easier. A value of 0.8 means that the hand will stand still for 0.8 seconds and then move for 0.2 seconds. To be able to see the motion of the second hand more clearly when we do our tests, let's change the speed of the clock so it moves much slower. Let's set it to 90, 1/3 of the speed. So, to make this hand pause control actually do anything, open the second hand driver, add it as a variable, and name it pause. To create this hand motion, we can ignore the part that creates the correct angle and just focus on creating the correct time for the hand. Add 2 brackets around our floor var and insert a lot of space, moving the angle part away, giving us more room to calculate the current time. Here we have the expression that makes it stick to every whole second, like it currently does. Since the hand will continue to stand still some of the time, we will keep this part and instead just add more to the expression. To make it move, we need to add back the transition between seconds we remove using the floor function. So what we remove using the floor function, we will take back in a separate part. We can get this part using something called modulus. What modulus does is giving us the rest of a value. If we calculate modulus 4 of a value, it removes 4s from it until we have a value that is less than 4. Let's try it with a value of 10 to see how it works. Since 10 is not less than 4, it removes 4, so we get 6. Since 6 is not less than 4, it removes 4, so we get 2. Since 2 is less than 4, it stops. So 10 modulus 4 equals 2. In this expression, we want to use modulus 1. A modulus of 1 gives us just a decimal since every whole number has been removed. So let's add var modulus, which is just a percentage sign, 1. Floor var gives us the number without decimals, and var modulus 1 gives us just the decimals. Since we are adding the two, the hand moves completely smooth when we play the animation. It is like if we had just used a raw variable. The whole numbers plus the decimals becomes the complete variable. Now we have the two parts we need. One that is the standing still value and one that gives us the motion between seconds. All that is left to do is to make it stand still during certain parts and move during others. Since our hand pause has a value of 0.8, we want the second hand to stand still for 0.8 seconds and then move for 0.2 seconds. It is this rest part that creates the motion, so we only want it to be added during the last 0.2 seconds. For the first 0.8 seconds, we only want the part that makes it stand still. For the last 0.2 seconds, we want this rest to be added as well. We can do this using something called a comparison operator. A comparison operator compares two values in different ways, and if it is correct, it gives us 1, true, or if it is incorrect, it gives us 0, false. What we want to compare is if the rest is the same or bigger than the 0.8. If so, this rest part should be added, since it is time for the hand to move. If not, it shouldn't. So, let's write var modulus 1 bigger or equal pause. This checks if the rest is the same or bigger than the pause value. This part will now get a value of 0 if the rest is less than 0.8 and a value of 1 if it is 0.8 or more. The great thing about this getting a value of either 1 or 0 is that we can use it to turn on or off other parts of our expression. We can do this by multiplying this comparison with the part we want to turn on or off, the actual rest. When the comparison is 0, we will get the rest times 0, essentially removing it, and when the comparison is 1, it will take the rest times 1, keeping its value. So when the rest is less than 0.8, we get floor var plus 0, making it stand still, and when it is 0.8 or more, we get floor var plus the rest, making it move. And now the second hand only moves during the last fifth of the second. Great. However, it doesn't start moving from the beginning. It jumps to 0.8 right away when we start adding the rest, since that is the value of the rest. So, we need to remove the 0.8 from our rest, making it start from 0. Add minus pause to the rest, and now the hand starts moving from the beginning. However, it doesn't move the whole distance. Since the hand now has less time to move from one second to the other, it has to move faster. At a pause of 0.8, the hand only has 0.2 seconds to move the same distance. So, how much faster does it have to move to cover the same distance in 0.2 seconds? 1 divided by 0.2, which equals 5. 0.2 is 1/5 of a second, so it has to move 5 times as fast to move the same distance. So to give it the correct speed, all we have to do is to divide it by 0.2, the time it has to move. Or to speak in general terms, 1 minus the pause. So let's divide it by 1 minus the pause. And now it is working like it should. It stands still 80% of the time, and when it moves from a whole second to the next. However, what happens if I set the pause to 1? The driver brakes. Having a pause of 1 means that the hand has no time to move. This is the same issue as when we tried to set the speed to 0. We are dividing by 0, which we can't. We have to set the maximum value of the hand flow to be slightly less than 1. And activate the driver again. And now it is working. Great. All the functionality of the clock is complete, so all that is left to do is to make some small adjustments to make it ready to be used. One of those things is to make the clock empty the master control for the entire clock. Before we parent everything to the clock empty, we want to move it to where it is supposed to be. Wherever the center of the empty is, will become the center of the entire clock. To make it easier to place on walls, I want it to be right behind the face of the clock. So select the empty and move it 0.07 units along Y, the same as the thickness of the clock face. Parent all the parts of the clock to the empty, so everything can be changed by just moving it. Notice that I didn't parent the time empty. Since the time empty is just used to give us values to drive the rest of the clock, it doesn't actually have to follow with the clock when we move it around. It can stay in the center, unaffected of where the clock is, and still do its job. Since it will be doing its job in the background, we can just hide it. Just a quick note, if you do choose to parent the time empty to the clock empty anyway, remember to switch from world space to local space in your drivers. Otherwise, the time of the clock will change when you move it around in your scene. For the latter, I turned on X-ray for the armature so every bone was always visible, but since the clock empty has the shape of a sphere, I don't have to. It is already visible from every angle, and we can't change the shape of the clock in any way that would cover the control. Finally, let's turn off the viewport selection for everything except the clock empty. There is no reason for us to grab any other objects. And that's it. This concludes the tutorial on creating an analog clock. I hope you have learned something. Thanks for watching.